In the casting industry, we are constantly seeking ways to improve the manufacturing process of cast iron parts, with the goals of achieving higher quality and more cost-effective products. One crucial factor in this endeavor is maximizing the metallic yield, as it directly impacts production efficiency and profitability. There are numerous advantages associated with achieving a higher metallic yield. It not only reduces the need for grinding and improves the utilization of the installed melting capacity but also leads to cost savings. This results in cast parts that offer better cost effectiveness. But how to improve metallic yield? Iron castings is one of the few liquids that during the solidification phase is accompanied by an expansion process, coming from the graphite expansion. Over the years, various technical articles have documented this physical phenomenon. As early as 1722, the French writer Réaumur published the Memories on Steel and Iron, mentioning an expansion process during the iron solidification, which continues to be an area of research today. Other studies address the first scientific attempt to measure graphite expansion in cast iron by Schmidt et al. And focused on the measurement of volume changes during solidification. Also, ductile iron consists of primarily two materials, a steel matrix surrounded by graphitic nodules. The steel matrix can be ferritic, perlitic or martensitic, or a combination of any two. The steel matrix will shrink considerably when cooling from 2000 degrees Fahrenheit to room temperature. Offsetting this shrink is the transformation of dissolved carbon into nodules of graphite, which occupies 9 to 11% more volume as graphite than as carbon. The natural shrinkage that occurs during the solidification of ductile iron can be offset by the expansion caused by the formation of graphite. In addition, ductile iron can be produced without risers if mold is suitably strong. This normally means using a no-bake rather than a green sand mold. Green sand molds must be as strong as possible to avoid shrinkage induced by wall movement. Graphite expansion is an important aspect of the process to improve metallic yield, however, has not received the attention it deserves. During the cooling phase at the molding line, the effects of graphite expansion become visually apparent due to the cracks on the sand mold. To overcome the shrinkage formation, it is necessary to control several factors in the melting and pouring process of iron, aiming to maximize metallic yield. In the study titled Understanding Graphite Expansion During the Eutectic Solidification of Cast Iron Through Combined Linear Displacement and Thermal Analyses, researchers investigated the expansion and contraction processes that occurred during the cooling and solidification of liquid iron. These processes were identified as the primary cause of shrinkage in castings. The study emphasized the significance of graphite expansion in counterbalancing the shrinkage resulting from the solidification of an austenite. According to the same study, graphite expansion increases with carbon equivalent for all types of irons, with ductile iron exhibiting considerably more expansion than compact graphite or lamellar graphite irons. Another study by Gelson Montero, titled Green Sand Molding Process Review, involved measuring and analyzing variables during casting solidification. The experiment revealed that the force generated by graphite expansion reaches 22 psi, which represents the minimum green compression strength required to contain the graphite expansion. If it is below 22 psi, the mold will develop cracks. Now that graphite expansion has been proven, the question arises, how can we harness the advantages of graphite expansion forces in our process to improve metallic yield? How to contain the expansion force of graphite for the benefit of yield to produce cost-effective casting parts? The answer lies in the revolutionary KÜNKEL WAGNER tight flask TwinPress process, which offers total control of machine stroke ranging from 0 mm to 80 mm. The optimal stroke figure is determined by achieving the best part results, specifically higher green compaction strength, which aligns with the goal of increasing yield. TwinPress consists of 4 steps. 1. It all begins with carefully filling the mold with sand. 2. The support cylinders are in an extended position, and the support table moves up to its designated position. Multiple compression pistons press the sand. 3. The support table continues moving up while multiple compression pistons extend further into the sand. The extension is controlled by counter pressure. In the final compaction step, multiple compression plates continue to compact the sand using a defined squeezing. The TwinPress 3.0 with variable displacement animation shows adaptation to pattern contours. Support cylinders are in extended position. Support table moves upward into position. Multiple squeeze pistons press into the sand. B. Twin press retraction of support cylinders. Support table moves further upwards. Support cylinders retract, holding the weight of the mold and the filling frame. Multiple squeeze pistons extend further into the sand. C. Final squeezing. Multiple squeeze plates continue compaction with defined squeezing. As evident, the best practice for producing cast iron parts is closely related to the concept of the Kunkel Wagner tight flask molding line. This approach allows for high green compaction strength and, consequently, higher yield. It is crucial to emphasize that achieving high green compression strength values, it also relies on using proper sand quality. Therefore, combining good sand quality with the KÜNKEL WAGNER tight flask twin press molding line is essential to produce high-yield parts. As an example, one of Kunkel Wagner's customers in Europe conducted a green compression strength control in one of their molds, utilizing the readings to evaluate the performance of the Kunkel Wagner tight flask twin press system. The results achieved were exceptionally satisfactory. Therefore, if your aim is to achieve cost savings through higher yield, twin press technology is the ideal choice. By holding the graphite expansion during the cast solidification process, the KÜNKEL WAGNER tight flask twin press develops a high green compression strength capable of compensate a significant part of liquid shrinkage, depending on parts geometry and other variables. In cooperation with many foundries in many different markets, it was possible to collect hundreds of data to evaluate the yield behavior in correlation with low, medium and high pressure molding process for gray and ductile iron parts. You can also ensure high-quality cast parts, increased productivity, and a competitive edge in the market. Another two important aspects comparing match plate flaskless versus KW twin press tight flask is the OEE and pattern plate utilization. The core setting operation in a match plate molding line interferes with the molding cycle. That means the machine cycle time stops to set the core. In a range of 20% to 25%, that means the machine OEE is heavily impacted, while in a tight flask line it doesn't interfere in the machine cycle time. In a tight flask line, it is not needed to stop the molding cycle time. The pattern plate utilization is another negative aspect of a match plate molding line compared with tight flask molding line. Per the manufacturer's specification, it is need a sand edge up to 2½ inch, depending on the plate size and part geometry, and an interlock figures around the pattern impression to prevent metal leakage and mismatch, both strongly reducing the pattern plate size utilization, or less impression per plate or a smaller part to fit the plate. In a tight flask molding, the sand edge distance from the flask surface to the pattern edge is around 0.6 inch, depending on the part geometry and tooling height. That means more impressions per plate capability plus a bigger part, for the same size of a match plate molding line. Match plate flaskless molding lines are definitively not the best practice to produce casting parts. Embrace innovation and maximize your company's productivity with the KÜNKEL WAGNER twin press solution.